हेलो एवरीवन, गुड मॉर्निंग। कैसे हैं सभी लोग? सो यस, गुड मॉर्निंग एवरीवन, वेलकम टू एग्जाम पर एंड टुडे वी विल बी डिस्कसिंग द प्रीवियस ईयर क्वेश्चंस फ्रॉम इलेक्ट्रिसिटी एंड मैग्नेटिज्म. So I'm waiting for the attendance from everyone. Who all are live here? Kindly give me your attendance. So yes, today we will be discussing from the electricity and magnetism part, and all the questions are from the previous year questions. And yes, just a second. Yeah. And yes, these questions will be from CPO. Then we have CHSL. We have all the examinations which are asked in the exam from the SSC part. So let's start with the first question. What is the first question? The first question is, the cause of magnetism in material is dash. Now this is from CPO 2006. If I talk about this question, we are talking about the cause of magnetism in the materials. So before moving forward with this question, let's have an explanation on this part. If I talk about this creation of this magnetism, let's see. What is it? What is a magnet? Magnet, if I talk about the magnet, we have two poles here. One is north, one is south, right? And we are also aware of this particular part. If we will have same poles towards each other, then they will be moving apart. That is, there would be repulsion. And if they are of opposite nature, that is, if one is north and another one is south, that means they are going to attract each other. It's as simple as it. But if I talk about this particular magnet, so this magnetism causes what? So there must be something because of which this magnetism is there, right? So that is what? That is the electrons. These electrons are always moving. And if I see these options, so electrons are rest? No. Electrons are not at rest. Protons are rest. We are not dependent on the protons as well. If I talk about option D, that is circular motion of electrons. So this is going to be the correct answer, that is option number D. So if someone is asking you the cause of magnetism in the material, it is because of the movement of the electrons. So yes, circular motion of the electrons is the correct answer, that is option number D. And everyone who has joined the session, kindly like it and kindly give me your name so that I can start talking to you and clear up all your doubts. So yes, let's move forward with the next question. Uniform magnetic field is represented by dash. Now this is from MTS 2013. Uniform magnetic field. See, when we are talking about this magnets, we are aware of what will happen. There would be some magnetic field, right? Now why this magnetic field is there? What is the root cause of it? So that's obviously the answer is going to be the movement of electrons. That's for sure. But if I talk about the uniform magnetic field, these lines would be parallel. But if I talk about non-uniform, we have Navnita here. Hello Navnita, how are you? Good noon, good afternoon. If I talk about the non-uniform magnetic field, they would be quite like this, right? So yes, if I talk about the uniform magnetic field, what is going to be the correct answer over here? Here we will be having parallel lines. So here option number B is the correct answer. Next, what is the unit of electrical conductivity? Now, before moving forward with this question, I have a question. What is this resistance or resistivity? Resistance. If I talk about resistance, what is it? Whenever we are talking about the movement of electrons, there must be something which is trying to stop the movement of electrons. Now, with what intensity is it stopping that electron? That will give us the value, and in the terms of ohm. What I said? Ohm. See, the unit of resistance is ohm. Now, just opposite to this resistance is what? That is conductance. Resistance, conductance, they are actually opposite of each other. Resistance was just stopping the electrons because there is lack of movement. Whenever there would be lack of movement, we can say that there would be lesser electricity, or there would be lesser movement of electron. That means lesser electricity would be generated. But for the conductance, we need more movement with the electrons. So if I'll just talk about this example, that is resistance and conductance, they are exactly opposite to each other. Just go with the unit as well. See, OHM was ohm, and if I talk about this conductivity, just move backwards. OHM, it will be what? MHO. So in this manner, you will be able to click the answer in the main exam as well. So yes, Navnita, you are absolutely correct. The correct answer is mho. But if I talk about this ohm, it was for what? It was for resistance. So do not forget, what is the unit for resistance? That is ohm. And for the conductivity, we have mho. So it's exactly opposite to each other. Next, Who discovered the link between electricity and magnetism? So who was he? This is from Chsl 2015. Navnita, do we have this answer? Everyone else waiting for the answer, please. Do you have answer for this? And remember, he is the same person you must have watched 3 Idiots movies. There was a question that was asked. Virus asked a question. What is the logic behind moving of this electric motors? On what principle it works? So this one of the scientists is here who has actually given its funda. And yes, waiting for the answer, then I'll be discussing this. Everyone, I want the answer from everyone. I've given you the hint as well. Electric motors principle. What is that? Everyone. So Navnita has given the answer, that is Michael Faraday, and that's absolutely correct. If I talk about Michael Faraday, he was the scientist who gave the concept of electromagnetism, where I can talk about electromagnetic induction. So whenever you are asked with the question, these electric motors are working on which principle? So please remember, if I talk about the principle on which this, oh, we have Prajwal here. Hello Prajwal, how are you? So yes, I was talking about this concept. If I talk about the electromagnetic induction, this logic was given by Michael Faraday, and yes, he was the one who has given the concept of electromagnetism. And here we are talking about the link between electricity and magnetism, and that is what? That is electromagnetism we are talking about, and yes, Michael Faraday is the correct answer. Next, Tesla is the unit of magnetic field dash. So what would be the correct answer? This is from CGL 2014. And everyone who has joined the session, kindly like it and start talking to me so that I can go in the depth and explain many things, whatever doubt is there. So yes, everyone who has joined the session, kindly like the session. And yes, I am also good, Prajwal. I am also good. Waiting for the answer. Tesla is the unit of magnetic field dash. Is it induction, moment, area, or flow? What is the correct answer? We have just discussed about it, right? So yes, waiting for the answer, please. Answer, please. Yes, no one. Okay, so if I'll talk about this Tesla, let's try to understand. Whenever we are talking about the intensity of the magnetic field, the intensity of magnetic field is shown by this unit that is known as Tesla. So we have just discussed about it. We were discussing about electromagnetic induction, right? So there must be some unit. So yeah, so Prajwal is with B here. Navnita, what is your answer? What's your answer here? Okay, so yes, Prajwal is with B, but we were talking about the electromagnetic induction. So please remember, if I talk about the electromagnetic field, we have Tesla as the unit over there. So yes, Navnita, answer was correct. So okay, Prajwal, yeah, now it's correct. So in the first good, no issues, but your answer is correct. That's important. Next, resistance of a conductor increases on what? This is from SSC Steno 2014. Resistance will increase with which factor? Increasing length, decreasing area of cross section, increasing temperature, or all of these? What is going to be the correct answer? And everyone is requested to kindly answer this. All these questions are very important. So yes, answer please. Waiting for the answer. So we have D. That's right. See, whenever we talk about the resistance, we know that it is what? Rho L by A, right? So let's try to relate it. If I talk about this rho, this is what? This is resistivity. L, that is length. So if I'll increase them, your resistance is going to increase, but it will decrease upon the increase in area. So we have option decrease when area of cross section is increased. So yes, decreasing area of cross section will increase the resistance. That's true. If I talk about the length, it is directly proportional to the length, right? So if length will increase, resistance will also increase. And also remember, whenever there is the increase in the temperature, then also resistance increases. That means all of the options which are given here are correct. So all of these would be the correct answer. And this question is asked many times in the examinations. So we have example official application here, where we have live paid courses with the test series, free subject wise, topic wise quizzes with the report card, job alert, admit card, exam wise PDFs, daily current affair, weekly current affair. Just go to the Play Store, type examport there, click on the install button, click on the open part, restore it and start using it. Yes, which of the following is rated in the electric bulb? Whenever you buy the electric bulb, what all things are mentioned? So let's have a look. This question is from metric level 2006. First of all, please give me the answer, then I'll move forward with this. Yes, answer please. Answer please. Who can give me this answer? You can just have a look at the electric bulb which is there at your home as well. So what will be the correct answer? Which of the following is rated electric bulb? So is it power and current? Is it power and voltage, current and voltage, energy and current? What is the correct answer? So Prajwal is with B here. That is sub power and voltage. So Navnita, are you also with the same answer? Navnita, are you also with the same answer? Okay. So Navnita and Prajwal both are with power and voltage. And that's true. Whenever we'll talk about bulb, we know that is mentioned. It is 100 watt bulb. It is of 200 voltage. So you will get this W and V. That is what? What is representing the power? Now this is asked in the examination. This is a very basic question. What is the unit of power? So you can just relate. I have the power. मैं किसी की भी watt लगा दूंगा. So yes, you can relate it with any of the examples. So where we have power and the unit is watt, and V that is given here is actually voltage. So yes, we can say that power and voltage is going to be the correct answer. Next, chemical energy is converted into electric energy. Where? This is from metric level 2002. Is it dynamo, electric fan, battery or atom bomb? What is the correct answer? Everyone please. Need the answer. Please, waiting for the answer. And yes, we'll go in the super fast manner. Wherever we require this explanation, we'll go for it. But answer please. Chemical energy into the electric energy. See, if I talk about dynamo, here what is happening? We need to convert mechanical energy whenever we are doing what? We are actually rotating that, right? So mechanical energy is actually converted into the electric energy here. If I'll talk about electric fan, what is there? There electric energy is there where it is starting rotation. That is, electric energy is converted into the mechanical. But here, Prajwal is with C. That is, Prajwal is saying it's a galvanic cell or battery. Okay, so Navnita, you are totally correct. Here the correct answer is battery. So Prajwal, Navnita, great. So if I'll talk about the battery, we know that electrolytic solution and all those concepts. So in short, I'll say that what is happening there, the chemical energy which is stored there is actually converted into the electrical energy, because of which your lights, fans and all are working. So that's true. Option number C is the correct answer, that is battery. Next, certain substances loses their electrical resistance completely at super low temperature. Such substances are called what? Now this is from CGL 2014. Waiting for the answer. Certain substances loses their electrical resistance completely at super low temperature. Such substances are what? Now before going to the options, just have a look. Electrical resistance. This means what? Sorry. If there is the movement of electrons, there is no one to stop this. So yes, what I was saying, if I talk about the movement of electrons, if there is someone to just stop that, we say that that is actually what? Resistance. What if I actually remove this resistance? So these electrons will easily move, and when there would be easy movement of the electrons, this means electric current would be there. So yes, Prajwal is with C, Navnita is also with C, that is dielectric. Okay, so again, Navnita is with A and Prajwal is with C. Okay, so Navnita is saying the answer would be superconductor and Prajwal is with C. Is there anyone among us who wants to change your options? Because I am going to explain it in one more manner. Let's have a look. Just tell me one thing. Have you listened? If I'll talk about current. So whenever we talk about current, the thing which comes into our mind is electricity. But it's not that. Let's try to understand. Here there's a water that is falling. This will give you better clarity. Here from the height, there's a water that is falling. Fine. So this movement of water or the flow of water gives us what? This is actually the water current. This doesn't mean that there is electricity. Please remember, this movement of water is telling us that this is actually the water current. That is, you must have listened it in the geography part. Ocean currents. What are these ocean currents? Do you seriously think that there would be current that is flowing in this ocean? No, that is actually the movement of water. Fine. So the movement of water was what? Water current. In the similar manner, if I talk about electric current, that is, I am talking about electricity. What is there? There is the movement of electron. There is what? There is the movement of electron. And yes, please remember, because of the movement of the charges only, electricity is generated. For example, if I talk about charges, they are of two types, either positive or negative. So if we are talking about the positive charge flow over here, in the same direction current flows. This is asked in the examination. But if there is the movement of the negative charge in this direction, the current will flow in the opposite direction. It is very important. Do not forget. Fine. So got my point. So here when I'm talking about the current, so it is what? It is the movement of electrons, because there is the movement of charges. So now what happens if someone is stopping this? We say that that is the resistance over there. That is, resistance is actually doing what? It is creating the hindrance in the flow of electrons. And conductance is what? It is actually allowing the current to flow. Now let's have a look. When we are talking about those substances which lose their electrical resistance, that means easily electrons can flow. That is, easily electricity conduction would be there. Easy generation of the electricity would be there, or easy flow of electron would be there. So yes, they are actually superconductors, where you can talk about the aluminium and all. So these are superconductors where whenever there is the lack of what we say temperature, that is at very low temperature as well, the electrons can start moving. That is, there would be the lesser resistance. So I guess my point is clear to you all. Superconductors are the one from where easily electrons can move. Okay, cool. So yes, superconductor was this. But if I talk about semiconductor, this is actually different. From the name itself, it is clear. What is it? Semi. Now I'll explain about it. I have one more question regarding this. Let's move forward now. The substances having infinite electric resistance are called dash. From Cpo. And again, I have explained the resistance part, right? So I guess this time your answer would be correct. The substance having infinite electric resistance, they are known as what? Infinite electric resistance. This is from Cpo 2012. Is it conductor, insulator, resistor, or electrolyte? And everyone who has joined the session, kindly like it and share it. See, infinite resistance is there. They are not allowing the electrons to move. So here, let's try to understand. If no one will allow the electrons to move, do you seriously think that current will flow? No, current is not going to flow if there is infinite resistance. Now we can take its example. The room in which you are sitting, you have actually locked the door. Now when the door is locked, do you seriously think anyone can enter? No. But in spite of that door, you have just put a cloth for the entrance. So someone will ask, Prajwal, can I come in? Nabnita, can I come in? So here the resistance is there, but it is not of that level that that particular person cannot come. Fine. So in the similar manner, if I talk about this current, when electrons will not flow, it's very obvious that there would be no conduction of electricity. So we have Solanki here. So yes, Solanki, good afternoon. So yes, here the correct answer would be insulator. That is, it will not allow the current to pass. Next, what is the conductivity of superconductor? What is the conductivity of a superconductor? This is from Chsl 2015. I think there would be no requirement of explanation here. And everyone who has joined the session, kindly like it and share it. Yes, we have already understood conductor, which is allowing the current to pass. And yes, we are talking about the conductivity, opposite of resistivity. Remember, resistance was doing what? No current, you will not be allowed to pass. That means there is no electron that is passing, so electricity is not generating, or there is no such electricity concept. But here what is asked? What is the conductivity of the superconductor? Remember superconductor? Yes. So Navnita is saying, sir, it B. That is infinite. Absolutely correct. So when I talk about the conductivity of the superconductor, it would go to infinite level. Correct? So easy flow of electrons, infinite conductivity. Next. Next question is, what is the resistance of an ideal voltmeter? What is the resistance for ideal voltmeter? Now what is voltmeter? From the name itself it is clear. Just have a look. Voltmeter. So the meter, just have a look. So the meter that is measuring the voltage. The meter that is measuring the voltage is what? Voltmeter. Now if I want to measure this voltage in any of the circuit or any of the device, if I talk about its resistance, what it should be? Should it be infinite, zero, high, or low? What? So Navnita and Prajwal, what is the answer over here? It should be infinite, zero, or low. And others who have joined the session, kindly tell me your name so that I can start conversation with you. And yes, please remember, if I'm talking about the resistance of an ideal voltmeter, it is going to be infinite. Please remember, it is going to be infinite, and option number A would be correct. Next, device used to convert AC into DC. Now this question is very important. I'll tell you why. Because there are two questions. One is DC to AC and another one is AC to DC. These questions are asked many times in many of the examinations, so do not forget about both. First of all, I want the answer for this. Device used to convert AC into DC. What is going to be the correct answer? So Prajwal, I guess I'm getting your comments quite late. Yeah, your answer was correct over there, Prajwal. But here, what is the answer? So we have Deep here, and yes, Deep is with answer D. Prajwal is with D, that is rectifier. Cool. So yes, if I talk about the conversion from AC to DC, that is we are talking about the alternating current into the direct current. What is the correct answer? The correct answer would be rectifier. Hello Deep, how are you? And Namrita, you are also correct. The correct answer is rectifier. What if I ask you direct current into alternating current? What would be the correct answer over here? And let me give you the options. The options are, the first one would be rectifier. Second one, do you need seriously options or should I directly give you the answer? Are you aware of this question or not? If yes, only then I'll give the options. Everyone, Nabnita, Deep, we have Prajwal here. Everyone who is there in the session, are you aware of this part? Otherwise, I'll give you the answer directly. Because both the questions are very important. AC to DC and DC to AC. Waiting for the answer. Generator. See, Prajwal, its answer would be inverter. The answer would be inverter. Please remember this. Fine. Because both the questions are important for the examination. So it is asked many times. So, okay, this answer was rectifier. Next question, please. The solids which conducts the electricity at high temperature but not at low temperature. These are what? This is from CGL 2013. So, Nabnita, Deep, Prajwal and all the others who have joined the session, kindly like it and share it. And yes, you all are requested to kindly give me this answer. The solids which conducts the electricity at high temperature but not at low temperature. These are what? Are they superconductor, semiconductor, metallic conductor or insulator? What is the correct answer over here? So Prajwal, Nabnita, Deep and everyone who is in this session want answer from everyone. What is the correct answer? The solids which conducts the electricity at high temperature but not at low temperature. So we have discussed about superconductor, right? We are decreasing the temperature. Even then, the current was flowing. Superconductor. Nabnita is with C, that is metallic conductor. Please remember, if I talk about semiconductors, these are the ones which are able to conduct the electricity at the high temperature. But what happens if I talk about low temperature, there is no such conductivity. So these are semiconductors. Fine. So if I talk about the semiconductor devices, for example, if I talk about those chipsets which are there in the mobile phones, laptops, they are made up of what? Silicon, germanium, remember? So yes, here what is the correct answer? The correct answer is going to be semiconductor. That is option number B. Nabnita, absolutely correct. Next. The metal used in wires at domestic level is what? Now this is from Steno 2014. Is it nickel, aluminium, iron or copper? What is the correct answer? And everyone please note it down. All these questions were previously asked and are very, very important. Because these questions are repeatedly asked. Some of the questions might look basic, but they are very important. Yes, answer please. So Prajwal is with B. Sorry, Prajwal is with D. Deep is sure that the answer would be copper. Others? Nabnita is also with D. And yes, answer copper is absolutely correct. But if I talk about the conductivity of this current, so the best conductor is what, do you know? Which is the best conductor? Everyone, want the answer please? Let's see who would be the first one to answer this. Is it Deep, Prajwal or Nabnita? Best conductor of electricity. And also, is that option present in these particular options? Best conductor of electricity is what? Is it nickel, aluminium, iron, copper, silver, what? Or gold? You are having all the options. Now, I am writing this question because whenever I am giving another question, that is very, very important. It is asked in the examination. So, Deep is the first one to answer this. Awesome, Deep. That's right. If I talk about silver, silver is the best conductor of electricity. Fine. So silver is the best, but we are not using that silver because it is actually costlier. And yes, at our homes, we are using copper wires. Very good. Next. Fuse wire used as a safety device in domestic electrical appliances is made up of metal having what? So this is from Steno 2011 and Chsl 2010. What is the correct answer here? That's true, Prajwal. That would be silver. Totally correct. What about this question? Fuse wire used as a safety device in domestic electrical appliances is made up of metal having what? Low resistance, low melting point, low conductivity or high melting point. What is the correct answer? Waiting for the answer please. And everyone is requested to answer this, please. Yes. So still, Nabnita is the first one to answer this. Nabnita is the first one to answer this. That is B, low melting point. Others? Don't you think it should go with the high melting point? Prajwal, Deep, waiting for your answer, please, so that I can explain this part. Prajwal is also with B and Deep is also with B. Okay, let's see. Whenever I'll talk about fuse wire, it must look like this, right? I'll use another color to explain this. Yeah, this is the fuse wire. Now, when we are inserting the fuse wire, what is happening there? In case heat is generated, and whenever there's a lot of heat, what will happen? This wire will break and this circuit will break, and that means there would be cutout, right? But what if it is having the high melting point? If it will have high melting point, when everything would be done, all those there would be fire, everything would be done, only then this will melt and this would be of no use at that time. So please remember, you all are correct, absolutely correct. Whenever we are talking about the domestic appliances, there we are using this wire with the low melting point, so that whenever there is a slight increase in the temperature, it might melt and it will just break the circuit over there. So you all are correct. The correct answers would be what? Low melting point. That is option number B. Next, for which type of the following Ohm's law is correctly applicable? This is from CHSL. For which of the following Ohm's law is correctly applicable? This is from CHSL exam 2013. What is the correct answer? Ohm's law. You remember Ohm's law? Ohm's law used to state about V equals to IR. Remember? V equals to IR. So what was it? It was told, yeah, when all the damage would be done. That's true. So that's why we are having the low melting point over there. But waiting for this answer. For which of the following Ohm's law is correctly applicable? Is it insulator, semiconductor, conductor or superconductor? What is the correct answer here? So Nabnita is saying that it would be C. That is conductor. Okay. Others? The Prajwal, waiting for the answer so that I can explain this part. Ohm's law. What it used to state? Ohm's law was telling, whenever we are talking about the voltage, voltage is directly proportional to the current. V is directly proportional to the current. Now, if I need to remove this proportional sign, what will I do? I'll put a constant value, that is R. So this means this is the relation, and this relation is for what? This relation is actually for the conductors. And what is conductor? Conductors are the ones which can allow easy flow of the electrons. That is, easy flow of the electrons means what? Easy flow of electrons would be there. That means easily electricity will be produced there, or there would be electricity there. So yes, if I talk about conductors, so here Ohm's law is applicable, that is V equals to IR. Next, which of the following is the best conductor of electricity? We have discussed this question. It's a very easy one, so no need to explain, but I need the answer from everyone. Which of the following is the best conductor of electricity? Is it copper, iron, aluminium or silver? So we have discussed, if I talk about my home, in our homes, we are using copper wires. But if someone asks you about the best conductor of the electricity, that's very obvious. The correct answer would be silver. So I'll not be waiting for answer from you all. But yes, this is the important one. We must remember. Next, current carrying conductor is related to what? SSC MTS 2014. This answer is required from everyone. So Deep, Navnita, you all were correct. But I want answer for this one. Current carrying conductor is related to what? Is it magnetic field, electric field, electromagnetic field or electrostatic field? So require answer from everyone. Answer please. So answer please. Yeah. Current carrying conductor is related to what? Is it magnetic field, electric field, electromagnetic field or electrostatic field? See, these questions are important. Need to discuss. Wherever I'll take time, that means that would be the important one. I have to explain something. We'll start with the story of Henry Oersted and then we'll come to this part. So Navnita is with C over here. That is, sir, it would be electromagnetic field. Okay. Others? Deep is also with C. Sir, it would be electromagnetic field. Fine. What about Prajwal? Prajwal, do you also want to go with C option? Do you also want to go with the C option? Because I'm going to explain this part now. But I want answer because I'm sure if you're wrong here, you will be 100% correct in the main examination. This is from my past 6 years of teaching experience. Okay. I'll come at my point. If I'll talk about the flow of electrons, whenever electrons are flowing, we know that there would be generation of electricity. But please remember, whenever we are talking about the flow of electrons, we are talking about the flow of electricity over there or electric current. So whenever we will talk about the current carrying conductor, please remember there would be magnetic field that would be generated. Please remember, again I am saying, whenever we are talking about the current carrying conductor, that is current is there, so around it there would be magnetic field. Fine. Now I'll give you the story what happened when there was Henry Oersted. When he was discovering all these things, he actually discovered and told that what is happening whenever current is there, current carrying conductor is there, there would be magnetic field that is generated. Now what happened later on, after a few years or after a few time period, there was another scientist that was Michael Faraday, and Michael Faraday was with the concept that here the concept was explained when current is flowing, there is electric field, sorry, that is magnetic field that is generated. But what he told, just he took the replica of this part, or I'll just say he was the vice versa of this concept. He told, what if we say that magnet is moved, and because of that electric field is generated. Please remember what I am saying. In the starting it was told that because of the flow of current there was a magnetic field that was generated. But now Michael Faraday came up with the concept, if magnet would be moved, there would be electric field that would be generated. Totally opposite to each other. So yes, when we are talking about this current carrying conductor, it is related to the magnetic field that is actually generated. And when we will talk about the movement of these magnets, their electric field is generated, just opposite to each other. So yes, here option number A would be the correct answer. Next, so we have example official application here, where we have live paid courses with the test series, free subject wise and topic wise quiz with the report card, job alert, admit card, examination date. Then we have free examination wise PDF. We have daily, weekly, monthly current affair, just as a single platform. Just go at the Play Store, type example over there, click on the install button, click on the open part, do registration and start using it. So it is a one platform where you will be having everything. Yes, metal used for the manufacturing of lightning conductor is what? Metal which is used for the manufacturing of lightning conductor. This is what? This is from SSC section officer 2006. The correct answer please. And yes, when we are talking about the metal which is used for the manufacturing of lightning conductor, this is what? So before getting your answer, let me explain this part. If I'm talking about a building, what can happen? Whenever there's a lightning, what can happen? If we talk about this lightning factor, it may damage the building. So what happens? If we'll put something over here, so that whenever we'll talk about the lightning effect, all those charges which are coming here, they'll directly go to the ground, that is earth. So this particular thing is made up of what? This is actually asked. So my question is, metal which is used for the manufacturing of lightning conductor, it is made up of what? Is it iron, aluminium, copper or zinc? So Nabnita has given the answer that said it would be C. Others need answer from everyone, because this is the important question for the examination. Everyone please, what is going to be the correct answer? The metal which is used for the manufacturing of lightning conductor, is it iron, aluminium, copper or zinc? What is the correct answer? And we have discussed, if I'll talk about the electric wires, yeah, that's true. Because of this, our building will be safe and sound, right? So again, I am writing, I'll draw this part. If this is the building, we will have copper over here, fine. Because of which, whenever lightning would be there, whole of the charge would be entering into the earth, because of which there would be no such damage to the building. And yes, Prajwal, you are with C. That's absolutely correct. That is the copper would be the correct answer. Namrita, you are with A. That is iron. No. Namrita, here copper would be the correct answer. Here Prajwal is the correct. Fine. Sorry, Prajwal is with the correct option. So yes, please remember, copper is going to be the correct answer here. Next, we can find dash with the help of galvanometer. We can find what with the help of galvanometer? This is from SSC MTS 2008. What we can find with the help of a galvanometer? Can you answer this question? What can we find with the help of a galvanometer? Is it resistance? energy, current or temperature? What is the correct answer? After this question, we'll be having discussion on the theoretical part, what all we discussed. So yes, Prajwal is with A, that is a resistance, okay. Then Deep is with C, so that would is the current. Namrita is also with C, okay. Prajwal, please remember, whenever we'll talk about the galvanometer, it actually gives the deflection if there is the movement of current. Yeah, that's true. Whenever there's a movement of current, Acha, you are also with C, okay. I thought you were giving the option A. Yes, that's true. So whenever we are talking about the current, so whenever current is present, this galvanometer will show the deflection and it will be the proof that yes, current is actually flowing. So you all are correct. Prajwal, Deep, Namrita, you all are correct. The correct answer would be here, your current. That is option number C. Now, what all discussions were there today? Let's have a conclusion on this part. First of all, let me explain, and everyone who has joined the session, kindly like it and share it, please. And yes, let's start with the part. First of all, when we are starting with the electricity, we have many things to discuss over here. Whenever the term electricity comes into our mind, we are aware of there are the flow of electrons. There is the flow of electrons. But let me tell you how this electricity is actually generated. It is because of the flow of charge. Now, charges are of two different types, either positive or negative. Now, if I talk about the electrons, we are obviously understanding this fact that yes, when we are talking about the electrons, that means we are talking about the negative charge. Now, we were talking about water current, right? So there was a flow of water over there. In the similar manner, when we are talking about the electric current, there is the flow of charge. So this is clear with us. Now the question comes, when we are talking about this electricity, electric current, so this is actually of two different types. First one is AC, that is alternating current, and another one is direct current. So if I'll explain you with this part, please have a look. If I'll try to draw a graph, for the electric current, we'll be having this sinusoidal wave, right? But for the direct current, it would be like this. So here, my question is, if I'll talk about this alternating current and direct current, where I'm going to get the frequency 0? Where? Is it in the alternating or direct? Please remember what I'm saying. This question is actually important. In which of the following currents, either AC or direct, one of the option would be correct. Where am I going to get the frequency 0? Now this question is important. Why? Because in the examination, it is asked about frequency. If I talk about the unit of this frequency, that is hertz. We all are aware of that. So here, from seeing this graph, can you tell me, is AC or DC, which one is going to be the correct answer with the frequency 0? Can you just check with this graph? I have explained this graph when we were discussing waves, right? So who can tell me where we are going to get frequency 0? Where? Is it AC or DC? Prajwal is with DC. Yeah, that's correct. If I talk about the direct current, just have a look. There is a straight line, that is, there is no such sinusoidal wave. And whenever we talk about this frequency, this means we are talking about the number of oscillations in a unit period of time. Number of oscillations. And here we are not having any kind of oscillation, right? So yes, if I write about the frequency 0, so I'll write here. Here you will be having frequency that is equal to 0. Please remember this fact. Do not forget. Now, another thing. Now, we were talking about AC, DC, right? Now, if I want to convert AC into DC, alternating current into direct current, so which is the particular device which I am going to use and where we are getting this AC current? I want to ask. So first question is, AC to DC conversion is done by what? Is it inverter or rectifier? Is it inverter or rectifier? Everyone. Deep, I want comments from you also, because these are the important things which are again and again asked. We will be covering all those factors. After this, I am going to discuss the transformer. But before that, I want this answer so that clarity would be there. Yes, for conversion from AC to DC, right? So whenever I'll talk about from conversion to AC to DC, that is rectifier which is used. Now, my question is, if I talk about alternating current, where we are using it? So remember, yes, that's true. If I'll talk about Nabnita, Prajwal, both of you are correct. That's right. I'll just ask why there is a late comments that are coming. Just a second, Just a second. Yeah, so that issue is being resolved, Nabnita. Don't worry. Till then, let me tell you, if I talk about this alternating current, it is actually there in our homes. But can you tell me, where do we see this direct current? Do you have any idea? Where do we get this direct current? So yes, whenever you talk about the railways now, Indian Railways, you will get to know that there we are getting this direct current. Okay. So yes, these things are important. Now, let's come to the next point, that is transformer. Very important. Let's have a discussion on the transformer. What if I ask you, this transformer is used for what? So can you give me the answer? Everyone. Navnita, Prajwal, then we have Deep over here. Everyone. Hello Vikramaditya. Yeah, that's true. So Vikramaditya, can you answer me this question? Transformer is doing what? What is the work of transformer in a single line? And I am not explaining you in the first go because I know many, and this question when it is asked now, we go with the wrong option. So first of all, I want to know from you all, how many of you know what is the working of transformer? Why we are actually using it? Great man. So Prajwal is the first one to answer this, and this answer is totally correct. Actually, there is a confusion. Some people think, sir, it is actually helping in the conversion from AC to DC. Someone says, sir, it would be DC to AC. Please remember, this is the wrong concept. Transformer is not helping you in AC to DC or DC to AC conversion. Fine? Na Vikramaditya. Please remember this point. Again, I am saying there is no such concept of AC to DC, DC to AC. I guess I am not. Yeah. Am I visible, everyone? I thought that there's some sort of buffering that is going on. Is there any buffering that is going on? No, na? Okay. So what I'm saying, again I'll say, there is no such AC to DC or DC to AC concept. Please remember, in the examination when it is asked, we go with the wrong concept. No, that's the wrong one. Fine. This transformer is doing what? It is just helping in the step up and step down concept, which is actually for the voltage. That is for the voltage. I guess this concept is clear, everyone. Please do not get confused. There is no such concept of AC or DC to AC. Fine. Okay, Mega. Fine. So this is the point. Now, what is the step up and step down? We'll be understanding this. Yeah. Cool. So yes, now let's understand what is this step up. Whenever I'll talk about this transformer, see, here we are having the number of coils N1, that is N1, let us write this is N1, this is N2. We know that N1 is lesser than N2, that is less high. This is actually your step up transformer. Please remember, step up transformer, how you will be understanding what is step up and step down with these number of coils. Here number of coils are less, here number of coils are more. This is step up transformer, that is, it is helping in the increment of the voltage. But if I talk about this transformer where the number of primary coils, this is actually primary coil, this is secondary coil. If primary coils number are extra in comparison to secondary coil, so this would be step down. Just have a look, high to low, high to low. So that is step down. So it is helping in what? It is helping in the decrement of the voltage, that is from the higher voltage to the lower one. So is this point clear, everyone? This is the important one. Do not forget, whenever I am talking about the step up transformer, it is going to increase the voltage. Here it will decrease the voltage. I don't know what is happening. Just a minute, let me check, let me ask. Vikas sir. So I guess it is okay now. It was buffering actually. Okay, fine. Okay, it is okay now. Okay, fine. So please remember, when I am talking about the step up, it is increasing the voltage, it is decreasing the voltage. So please remember these facts. Fine. So okay, we have discussed about the transformer now. We have discussed about AC DC. Now moving forward, if I'll move forward and discuss more on this part, so we are talking about resistance, right? Resistance. So we know that its unit is ohm. What is resistance? We know everything. But now if I'll talk about the circuits, there was some buffering. I've just asked them to check. Don't worry, it will be resolved now. There will be no issue now. Okay. Now let's talk about the circuits. If I'll talk about the circuit, there we have resistances. See, here when there is a current I, we know that this current is not dividing anywhere. That is, their current is actually same. Wherever I'll check, current would be same. This is known as the series combination, where all the resistances, let it be 2 ohm, 2 ohm, 2 ohm, these particular resistances are present in the series because there is no division in the current. It is asked in the examination. Where current divides, that is in the parallel combination. In the series, there is no such division of the current. Just have a look. So if someone will ask you, what is the resultant resistance between points A and B? So for this, you can directly add. That is, total overall resistance would be R1 plus R2 plus R3. That is, 3 resistances are there. And if there is n resistors, then n. So that is correct. So if I'll just add them, so overall would be what? 2 plus 2 plus 2. That is, total would be 6 ohm. Right? Now, what if I ask you all, if the same concept comes now in this manner? So the current is like this actually. In this manner. So you will check that there was a current I which was flowing. Now there's a junction point, correct? So here what is going to happen? I1 current will go here, I2 will go here, I3 will go here. That is, current is actually divided into 3 parts. Now we have resistance of 2 ohm, 2 ohm, 2 ohm. Now the current was actually here I1, I2, I3. That means current divided now. Whenever current will divide, remember that combination is what? That is parallel combination. And here we will have I current again, because we will be having I1 plus I2 plus I3 again. So this will give you I1 current again, sorry, I current again. Got my point? So here someone is asking you about the overall resistance. So how will you calculate? Here Nabnita has already given the answer 2 by 3. Prajwal has given the answer. Very good. That's awesome. If I try to calculate it, it would be what? 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. So the question is asked, if we are dividing this particular concept into several parts, what will happen and so on. So before that, we must clear up with this concept. That is, 1 upon R will be equal to 1 by 2 plus 1 by 2 plus 1 by 2. That is, 1 by R is equal to 2. So it would be what? 3 by 2. So here the resistance would be 2 by 3 ohm. Got my point? So yes, this is the combination for the parallel part. Now we have understood the parallel and series combination. Now I have a question for you all. Let's have a look who can give this answer. There's a resistance where we are having the both combinations. What if what if we are like this? We are with this concept. So this is 2 ohm, this is again 2 ohm, this is again 2 ohm. So this is the point A, this is the point B, and I want the resistance for all this part, that is between A and B. What is the overall resistance? So who can give me this answer? Everyone. Needing answer from everyone, from each and every candidate. If that concept is clear, you can easily answer this. Then I'll explain. Prajwal, Nabnita, Vikram, Aditya, Megha, can you give me this answer? And everyone who has joined this session, kindly like it and share it. Everyone, please. Waiting for the answer. Prajwal is with 3 ohm. Nabnita, Vikram, Aditya. Is your answer also same? Nabnita is also with 3. Others, are you also with the same? If yes, then we can increase the level. Okay, Vikram, Aditya, totally correct. So yes, if I'll go with this part, I know that here the current was I. Till here, there is no such division, so I'll write 2. Now plus. Now let us assume this is another part. From here, the current will divide into 2 parts, I1, I2. This means they are in the parallel part. So I'll give the bracket, and here I'll write 1 by 2 plus 1 by 2 and try to solve this. So this would be 1 by 1. The overall resistance will get reciprocal. That is, it would be 2 plus 1, and we will be getting 3 ohm as the answer. What if? Totally correct. Awesome, everyone. Totally correct. Now let's try to make it quite difficult. Now my question would be like this. Here we have, this is of 2 ohm, this is again of 2 ohm. Then we have one resistance, that is 2 ohm. Then we have again 2 ohm and 2 ohm. Now what is going to be the correct answer in this point? Now I want the resistance between A and B. That is, I want the overall resistance between A and B points. So yes, answer please. And everyone who has joined the session, kindly like the session and share it as much as possible, please. Here, I guess you will be able to give this answer. Waiting for the answer, please. And yes, in the theoretical section, we'll be having more questions, more difficult questions. So Prajwal is with the 4 ohm, others 4. And Prikrama, you are left. Totally correct. Yeah, super easy, super easy. Please remember what we are doing. We are just dividing into this into 3 parts. This parallel as a 1 part we are taking, it would be 1. Totally correct. This is absolutely correct. That is obviously it would be 2 ohm. And if I'll go with this part, it will be again 1 ohm. So it will give you 4 ohm. Totally correct. Now, let's take the last question of the day and then we'll sum up. So here we are having the resistance of 5 ohm, 5 ohm, 5 ohm, fine. Yes, then we'll be having this part and then we can go with, yeah. This is again a simple one, but just wanted to ask you 10 ohm and 10 ohm. Yes, I want the answer between A and B. Yes, please. This is the combination. And yes, as same logic, we'll be going forward. We'll be dividing into 3 parts again. 1 plus 2 plus 3. Let's try to solve this part. If I'll go with this logic, it would be what? First of all, 1 by 5 plus 1 by 5 plus 1 by 5. That is 1 by R is equal to this, right? So here, everyone please, you also keep on solving. If I'll go with this part, it would be 3 by 5. That is overall resistance would be R is equal to 5 by 3, right? Here, we are having in between that is 5 again. So it would be what? It would be 1 by 10 plus 1 by 10. 1 by R is equal to 2 by 10. That is, it would be 1 by 5. So it is R is equal to 5 actually. 5 ohm. So 5 plus 5 plus 5 by 3. So 5 by 3 plus 5 plus 5. So what is the answer? Everyone, have you got the answer? So it is 35 by 3. That is with the Prajwal. Nabnita and Vikramaditya, still waiting for your answer, please. So it would be 5 by 3 plus 10. So it would be 35 by 3. Correct? So waiting for the answer, please. Nabnita, Vikramaditya, are you getting the same answer? Yeah. See, so why I kept these questions? Because whenever you are there with these type of questions, na, just go with the series concept. Because when we'll keep the series concept, na, it would be easier to solve. If you will try to mix them up, you will go with those parallel concept, it would create confusion. So I guess this part is clear. If this part is clear, then we'll be meeting with the theoretical section in the evening. Fine, we'll be having our topic, invention and discoveries. And tomorrow, we'll be having the same theoretical section where we'll be having light and electricity. Electricity and magnetism. So yes, Vikramaditya, your answer is also correct. Cool. Okay then. So we'll meet up in the evening. Fine. So there's a last question of the day. And the last question is, multimeter is used to measure what? This is from SSC text in 2006. Is it current, voltage, resistance, or all of these? Please answer me this so that we can then proceed and we'll meet up in the evening. Multimeter is used for what? Is it current, voltage, resistance, or all of these? So please remember multimeter. From the name itself, it is clear. It is multimeter. Meter for multiple things. Voltage also, current also, resistance also, everything. So here option number D, that is all of these will be the correct answer. So everyone got my point? Multimeter. Yeah, that's true, Prajwal. Great. So okay then. Bye-bye everyone. Please take care. For any kind of doubt, you have comment section. Please let me know. I'll resolve all your issues. Fine. So meet you all in the evening between 6 to 7. Till then, bye-bye. Please take care.